Those are some models we can use for companies that have some market power, but we could do a little bit better. So beyond the one price per unit model where we set a quantity, what if we have different circumstances where we can extract more profit? So we're going to look at different categories, how this might occur. The first is we have pricing strategies that extract surplus from consumers. Next is where there are special cost and demand structures. And third, where there are markets with intense competition. First, let's look at those that extract surplus from consumers. And within this group, there are four: price discrimination, two-part block, and commodity. And each one is different based on circumstances that you face in your particular business. The first is first-degree price discrimination. The pictures here aren't just random pictures. One of the examples of this is going to buy a car. One of the most painful things people do. They walk in a dealership not knowing what they're going to pay for the car, and neither does the salesperson. So what this idea is, every consumer has a price they will pay for a good, and that price will vary from consumer to consumer. And if you aggregate it, it will approach a demand curve. So the idea in this particular sense is try to find the maximum price that that consumer will pay, and therefore you will sell at the maximum price as you walk down the demand curve. And that is what first degree price discrimination means, where each discrete purchase happens at the maximum price that consumers are willing to pay for that item. And the end result is we extract all the consumer surplus. Since it's not one price to all consumers, each consumer pays his or her own price. The problem is we rarely know this, and it's quite difficult to have to determine this by each person. But this can be done to some extent. And if you've ever bought a car, you know pretty much that if they sold 10 cars, they might be at 10 different prices. Let's look at how this would work in terms of capturing the consumer surplus. Let's start with the demand curve and marginal cost. And if we only had to pick one particular price, we would pick where the quantity of 5 intersects the demand curve, and we would have a price of 4. So this is how we would derive it. We've done that many times. And our profit would equal the gap between the revenues and the total costs. And that equates to the orange box that we see. But what would happen if we could somehow not sell at one price, but what if we could walk down the demand curve, sell one at a time to each person to get maximum price? So it's not one price here where everyone gets that price. We're selling each person along this curve until such time as we've sold to everyone who's willing to pay equal to or above marginal cost. So we would capture this as our revenue, not some straight line where everyone pays the same. In that condition, we would capture all the consumer surplus too. We captured this orange triangle when we sold at one price, but now we're capturing the entire surplus too, because we didn't sell at this price. We sold at each discrete price all the way down this curve, down to this point, and we captured this triangle too. So in this case, we captured 100% of the consumer surplus. The second example is what we call second degree price discrimination. And this is where we have declining prices based on quantity. Here I have a bottle of wine. You might pay $40 for that bottle of wine, and you'd expect that if you bought it by the case or cases, that the price would drop. So this is an example of second degree price discrimination. So here we have the same idea of marginal cost and demand, and we then set two prices, one at $7.60 and the other at $5.20. And when we do so, we see that our profit equals these areas here. At $7.60, we would capture this darker blue region, and at $5.20, we capture this lighter blue region. But when we add those together, it's greater than if we merely charged a equal price to every single consumer. So this is called second degree price discrimination. We're not charging a different price for each quantity sold, but you're capturing more of that demand curve by having two prices. The other instance of price discrimination is third degree. And this example here with the movie theaters is you have AMC, you can go see a movie, and they have a sign that if you're a senior, that their senior day on Monday and Friday until 6 p.m., namely off-peak, that they get to see movies for $5. So this is an example of price discrimination not based on quantity, but the different demographic and the time of day. How this looks is we have two different populations and we have two different prices. So price 1 is 1 plus the elasticity for that first population divided by E, and then we do the same for the second population. So let's do an example. Let's move to pizzeria and not movies. The marginal cost is $6. The pizzeria is in a local monopoly near a campus. During the day, students go there to eat lunch, and in the evening, students may be studying, faculty members might eat there. So students would have a higher elasticity, and let's call it -4, and faculty might have a lower elasticity of -2. So what should the pricing be to these two populations? Let's solve the problem. So let's assume that faculty would be unwilling to eat cold pizza, so they'll won't buy it at lunch and reheat it. And so therefore we have an opportunity for price discrimination. So we can have a lunch price and a dinner price. What's in red is the formula. We just brought it forward for reference, but we could plug the numbers in. The price for lunch times 1 minus 4 divided by -4 equals 6. And the price for dinner times 1 minus 2 over -2 equals 6 also, the marginal cost. And when we solve them, the price for lunch will be $8 for a pizza, and the price for dinner would be $12 for a pizza.